In this video, I am going to show how to analyze a two-hinge arch subjected to a point load. For this, I am going to consider one example. So that is a semicircular two-hinge arch of constant cross-section is subjected to a concentrated load as shown in figure. Calculate reaction of the arch and draw bending moment diagram. So this we will draw by using STAAD Pro. So open the STAAD Pro. I am using Connect Edition and give a file name, give the location, select type as analytical, select unit as metric, and go to create a model. Then next, you have to go to structure wizard. So we want to create two hinge arch. We know that this structure is statically indeterminate structures, which require some additional equations or additional method to analyze. But we are using STAAD Pro. So in the STAAD Pro, first we will create the model, and then we will apply the load. So for this arch, only point load is acting, that is 40 kilonewton is acting at a distance of 8 meter from the left hand side support. So that we have to add. So let's create a model first. We'll go in structure wizard. Our structure is 2D structure. So for that we will create frame model. We will go to cylindrical frame. Don't go to reverse cylindrical frame because it will generate in the XZ plane. We want the two hinge arch to be generated in the XY plane. So the total length, we will see the total length. The total length is 30 meter and the radius is 15 meter. So I will go to again structure wizard. Then we will go to cylindrical frame. Total length is 30 meter. Then the radius is 15 meter. The angle, it is a semicircular arch, so the angle is 180 degree. Number of bays, it is only 2D structure, so the number of bays will be 0. And the number of bays along periphery, that you can keep more than 20 or approximately 20, because more you will discretize that two hinge arch, the more accurate results you will get in the STAAD Pro. So I will make it 20. I will say apply. So this is how a discretized two hinge arch is generated into structure wizard. So this model you have to transfer it to the main screen. So I will say yes, we will transfer it from 0, 0. Now we will go to view. We will see the front view of this two hinge arch. So this two hinge arch, we will just see the coordinates first, because later whatever load we are going to apply, the load we have to apply it on arch. So sometimes it will get difficult to identify the exact coordinate of that the arch, that is the load which is acting on that particular arch. X coordinate is given, but to identify the Y coordinate, it will be difficult with this problem, because this is not perfectly a semicircular arch. This we have discretized. Actually the discretized element are straight lines, but since it is discretized into 20 parts, so it looks like it is a arch in between any two nodes. So we will go to first properties. Since the properties, that is what is the property, cross-sectional property of this two hinge arch, that is the material, and geometric is not given, but we will assume any kind of specific property. So I will go to define. I will select any rectangular property considering the material as concrete. So let us say 0.5 is the depth, or 0.4 is the depth, and 0.3 is the width. I will assume that the material is concrete. Select it, add, and this cross section I will use for entire structure, that is entire two hinge arch. So whatever 20 discretized elements are there, so for that I am using the same cross section. So I click on assign to view. I will select assign. So this property is assigned to this all 20 discretized element. And then I will go to supports. So only two hinge support we have to create. So that is, we will go to create and we will go to pinned and we will go to add. So that is added. And then we have to assign it to bottom two supports. So select that bottom two supports, click on support, and then click on assign to selected nodes, assign. Yes, so that is support is also assigned. Now the next that is important thing is the loading. The load is only a point load, but it is not acting at a very specific point. Okay, So that means the x coordinate is given, but the y ordinate is not given. So y ordinate you can calculate in the manual calculations, but here, since it is not a perfectly semicircular arch, so we have to first identify where the actual, in which of the discretized part the 40 kilonewton load is going to act. So I will go to geometry, I will go to grids, I will select beam grid. Since it is only of 10 by 10 grid, so I will modify that grid into edit grid. I will add some 10 or let us say 15 grids in the left, 15 grids in the right, and I will add 15 grids in the y direction, such that my entire structure is occupied by that grid. So I'll say okay. Now the point load is going to act at -7 from left support and -7 from the 0, 0 ordinate. But this distance at this ordinate, that is this y ordinate, we don't know. So I will assume that this node at this node, my point load is going to act. That is my approximation. It will make the modeling easier. So to make the modeling easier, that's why I'm going to assume this concept in the STAAD Pro. So now I'm going to add this load. So go to load case details, select add, click on add button, don't change the name, let it be, and select load case 1, click on add button, and then go to nodal load. By that assumption, the modeling becomes very easy. So that is, the load is going to act in the y direction, but it is acting in downward direction. So select -40, just add it, close it. We have identified the distance, that is at this node. At this node, the load is going to act. Okay, so that is approximately, not exactly. If you want it more accurately, you discretize this entire frame or entire arch into more parts, 20, 30, 40, 50, whatever parts you want, such that you will more accurate results you will get. Then go to select option, select node cursor, because we want to apply this nodal load. So select this nodal load at this specific distance, select the node, select the load, select assign to selected nodes, assign. Yes. So this is the load that is going to be added. So now we will go to analysis, select the analysis command, select no print option, and then go to run analysis, select save. Now after analysis, it should show 0 error, 0 errors. Then we will go to modeling mode. We will go to then post processing. We want to see the reaction. So what are the reactions? Since there are 2 hinge supports, so 4 reactions are going to generate. What are the values? The horizontal reaction at both the support is constant, 10.149, and the vertical reaction is 29.080. Z reaction is not going to generate because it is a 2D structure. We will see what is the the moment, bending moment along the Z direction is going to generate. So we will see the values. Go to annotate option and see the beam results. Select only maximum bending moment, annotate, and see the maximum bending moment, that is the maximum negative bending moment, is going to generate in the left portion. That is, the value is -102.53 kilonewton, and the maximum bending moment, that is the negative bending moment, is 59.666. Actually, the sign conventions that we use as sagging positive and hogging negative is different in the STAAD Pro. Okay, so now if you want to see the deflected shape, go to displacement and just press the control button and scroll down. You can see the enlarged displacement diagram, and if you want to see the values, you can see this in this table. Okay, so thank you for watching.